In this module, we're going to talk about integrating ACI with virtualization. We'll give you a primer on virtualization, as well as talk about how we integrate ACI with VMware in terms of a traditional manner, as well as connecting with VMware using the VCenter plugin. We'll also talk about integrating ACI with Microsoft, as well as OpenStack, and we'll talk about the OpFlex protocol and how that can be used to configure policy across multiple types of devices. We'll talk about the AVS, the Application Virtual Switch, which is very similar to the Nexus 1000V, in fact share some of the same components. And we'll talk about design considerations involving virtualization, as well as the hypervisor integration roadmap.
First, let's talk about virtualization. By this time, when I first started teaching things like Cisco UCS, virtualization was fairly new to network administrators. It should be it should be a lot more familiar, but just to go over some of the basics here. On a bare metal server, of course, we've got hardware, we've got storage and memory and network cards and processors. We've got an operating system sitting on top of it, and we've got binaries and libraries and applications running on top of that. Virtualization, which has actually been around since the 1960s, but modern virtualization as we use it today, first really became popular in the mid-2000s when the processors started getting the VTX extensions. This allowed basically virtualization to not have any performance impact, or the ability for them not to have any performance impact. Whereas earlier versions of virtualization would sometimes have a significant performance impact. So once that happened, we could easily implement hypervisors. So a hypervisor is a layer that sits in between the hardware and virtual machines. So hypervisor presents hardware to a virtual machine. So the virtual machine thinks it's got dedicated hardware. It doesn't really know that it's not existing by itself on a given piece of hardware, and you can run operating systems and binaries and libraries and applications on top of that. So that's nothing new. We've been doing this for the past 9 years in networking for the most part. Now all of this needs network connectivity. The thing to keep in mind with hypervisors is that we typically will have a virtual switch sitting inside of that hypervisor. So this is a software switch that provides access for the virtual NICs. Let's do some drawing here. So right here, VMware calls these VNICs, and for some strange reason, this was called a VMNIC, or sometimes referred to as a PNIC, physical NIC. I think physical NIC is a probably more apt term. But these NICs here, these are the virtualized network interface cards that the VMs have. So the VMs have, they think they have an interface, and that plugs into a vSwitch, and then that vSwitch has an uplink to a physical NIC, and that physical NIC has an uplink into a physical piece of hardware. So that's one of our primary jobs as network administrators, is to provide this access, to be able to provide connectivity for that physical NIC. In VMware, we have the ability to do a distributed virtual switch. So a distributed virtual switch is a consistent policy, forwarding policy that we can implement across multiple hypervisors. So rather than going into each individual hypervisor configuring VLANs and port groups and so forth, we just do it once in a DVS, and then that gets populated to all of the hypervisors in that given cluster, those ESXi hosts in that given cluster. So those are the NICs. And a DVS will typically have port groups. So we might consider that a VLAN. In fact, usually when a port group gets mapped to the physical world, that gets mapped through VLAN. So the red VLAN might be VLAN 10, the yellow VLAN might be VLAN 20. But these are port groups. Devices inside of VMs that are attached to a port group have connectivity towards each other, typically, unless we do a private isolated port group. And then they'll have connectivity up to a physical switch through trunking. Typically, now not always, but typically what happens is that a packet will leave this VNIC here, enter in the DVS port group, and then when it leaves the host, let's say that the packet or the frame is destined for maybe a default gateway or a host in another DVS or a host in another ESXi host, it will get tagged with a VLAN. So we typically will map VLANs to port groups. Not always. We can map port groups to VXLAN, for example. But for the most part, right now in VMware, the most common encapsulation is VLANs, of course. So frame leaves this NIC, and typically DVSs are just layer 2 aware. The frame leaves this NIC, just a regular frame, enters the port group. The port group forwards it to the physical NIC. It gets the 802.1q VLAN tag header sent, and gets sent up to the leaf. Now this could be any device. It could be any kind of switch. So this is certainly not something that only Cisco ACI or Cisco switches in general could do. This is very common across the board. So this is the basics of networking, virtual networking inside of virtualized hosts. We can also have now containers, Linux containers, Docker and Rocket and so forth. Run a little slightly differently. They are a packaging system for applications. So a container will typically run an application or maybe a couple of applications. They can run their own libraries and binaries, or they can share libraries and binaries. They run on top of an operating system, but not a hypervisor. And we can provide connectivity there as well. So hypervisor integration. Policy coordination with the virtual machine managers. So VMM manager, VMM, a virtual machine manager, is VMM manager is a little bit redundant, so it's VM manager or VMM. Is the controller for a given hypervisor. For example, VCenter is the VMM for vSphere. And then Microsoft Service Center VMM is one of them for Microsoft. There's also Azure Pack. But what we can do is we can do network policy coordination with network policy coordination with virtualized managers. So, for example, when we deploy an endpoint, we can program that endpoint information into the API controller. When we create an EPG, we can create a port group, et cetera, et cetera. We can also support VM mobility. So when we vMotion, the VMM will tell the APIC, and the APIC will then make sure that we put a bounce entry in, and we've got some coordination there so that we drop the fewest amount of packets for vMotion. For the most part, it's likely that you're going to have, we're not likely, but it's very, very possible that you're going to have more than one virtual machine manager. So vCenter, of course, is probably the most prevalent of the virtual machine managers out there. But there's also a lot of System Center VMM and KVM or OpenStack. So all these are popular, and you might end up having all of them in your data center. You also might have more than one vCenter installation. So that's very common, too, to have multiple installations of vCenter. And that's counted in ACI as a separate VMM domain. So we call this a VMM domain. All of the VMs and the controller combined, we call that a VMM domain. One of the issues that we have with VMM domains is that, or with virtualization, is that most of the time the encapsulation is VLAN 802.1q, which is 12 bits, which only gives us about 4,000 network segments. That may not scale throughout an entire data center, especially as we start to shrink our network segments with things like EPGs. So what we can do is we can create pockets of locally significant VLANs or VMM domain significant VLANs, so that the VLANs that exist in one VMM domain can be separate than the VLANs in a different VMM domain. For example, this EPG here might use VLAN 10. And this EPG might use VLAN 10 as well, and these would be mapped to two separate bridge domains, to two separate tenants, possibly, and they would be considered separate networks. We can also bridge them together, so one VM domain can connect to another if we needed to, but by default we can keep them separate. And that way each VMM domain gets about 4,000 EPGs. And we can place the VM anywhere, and we can live migrate within a VMM domain. EPGs can take different network identities across VMM domains, so applications can be deployed across multiple domains, like we just mentioned. Right now, VM mobility is not allowed between VMM domain due to VCenter SC VMM limitations. Although that might actually be solved not with ACI, but with vCenter 6, because you can VM vMotion between two different vCenter instances. So in that case, you might be able to do that. So VLAN namespace can now be overlapping. We can use something that's called per port VLAN when VMM domains share the same top of rack. So even with the same top of rack, we can use the same VLANs and map them to different port groups, or map them to different networks. So, oops, sorry, I'm skipping around here. So for example, we got a leaf here. We've got a port group for VMware. And let's say we call this web app, or just call it app 1, port group web app 1. And we use the VMM VLAN pool, and we map this particular EPG, or it's a port group, we mapped it to an EPG. And we're encapsulating on VLAN 10. And that is going over E110. Over here, we've got a separate vCenter instance, and what we're going to do is, we have maybe app 7, just picking a number here, and so that gets mapped to a port group, which gets mapped to a VLAN, and maybe we're using VLAN 10. And that's on port E12. With per port VLANs, the VLAN significance becomes local to a given interface. So the VLAN 10 on or VLAN 10 on E12 is a different network, is a completely different network than the VLAN on E110. So that allows us not only to scale out VLANs across leaves, but we can also scale them out even inside of a leaf. So we get way more than 4,000 VLANs on a given ACI Fabric. And to configure per port VLANs, we go into interface policies. Under policies, it's one of those individual policy things. We go to L2 interface. There's a default policy. It's best to leave that for global scope. And then we create one called per port VLAN, PPV. You can call this whatever you like. And then we make the port local scope. So that way the VLANs are scoped locally, or locally significant to that port. And then on our policy groups, under leaf policies, and this is ACI 2.0. And before ACI 2.0, it'll just say policy groups. But after ACI 2.0, you'll see leaf policy groups. We go into a policy group where we pick the individual. This is the basket, basically, of all the individual policies that we've chosen to put into a single policy group, although we can have multiple policy groups. But this particular policy group, under L2 interface policy, we see here we have PPV as an option, so we can select that. All right, let's talk about integration with ACI and the VMware Virtual Distributed Switch. So, a couple questions here. How does the ACI Fabric implement policy? Well, we assign endpoints to endpoint groups, and then we apply policy on the endpoint groups. And what are endpoints in a virtual environment? Well, they're VMs, and more specifically, they're the VNICs on those VMs. So again, VMware has a term called VNIC and VMNIC. It's a little bit confusing. VMNIC you would think is this thing right here, but it is not. VMNIC is the physical NIC. Sometimes they refer to it as a PNIC. But in our case right here, we're dealing with the VNIC. So this is the NIC that the VM has. So that's the endpoint that we're dealing with. So how does VMware apply network configuration? Well, they attach a VNIC to a port group. And here we have a web port group, app port group, and database port group. So every NIC is associated with a port group. When you stand up a virtual machine or instantiate a virtual machine, when you go to the NIC configuration, you'll have a little drop-down menu of all of the available port groups. So how are EPGs exposed to VMware? Well, we map a port group to an EPG. So it's a one-to-one relationship, or it can be many to one, but typically we do an EPG and we'll map it to a port group. Endpoint identification. So there's a couple different ways we can identify an endpoint. If it's a physical host, such as a bare metal server, or even a load balancer or a firewall, we define it in the APIC on the switch interface and possibly VLAN. For virtual endpoints, they are created inside of VMware, and they can let ACI know, they can let the APIC know that they exist. And an endpoint group, when we create it, we can create a port group inside of ACI and vice versa, so we can have back and forth. So in ACI, if I create a port group, it can create if in ACI, if I create an EPG, it can automatically create a port group in vCenter. And with the vCenter plugin, if I create a port group in vCenter, it can automatically create an EPG in ACI. So we can do it both ways. Typically, a port group is mapped to a VLAN if we're using the VDS, the distributed VDS, and then VXLAN if we're using vShield. So how does the integration work between ACI and the VMware VDS? So number one, Cisco, APIC, and VMware initiate their handshake. So in ACI, we create an account. We create a VMware controller. And it contacts vCenter here. It's going a little bit quicker for me, sorry about that. So step number one is the APIC and VMware Center do their initial handshake. Step number two, APIC creates a VDS inside of vCenter. So this will be a distributed virtual switch, and this requires, of course, Enterprise Plus, typically in vCenter. So step number three, the hypervisor we attach the hypervisor to the VDS. So we'll add hosts. We'll go to the VDS and we'll add some hosts. So these are the ESXi hosts. Step number four, where did step? Oh yeah, we learn the location of each ESXi host through either CDP, LLDP, or now pre-provisioning. So that requires that the VDS be running CDP or LDP, or we can pre-provision if we don't want to run either of those. Either way works fine. Step number five, we create the application policy of this. So this is the ANP, the application network profile. Step number six, we automatically map any EPG that we create in the ANP to new port groups inside of vCenter. Number seven, the APIC creates those port groups. And 8, we instantiate VMs, and then we assign them to those port groups. And once we assign it to a port group, they automatically get added to the EPG. And then step number 9 is the APIC will push the policy on demand to the leaves in the ACI Fabric. So starting VMware integration, first thing we're going to do is create a VM management domain. And then in ACI, we'll create a VDS, in vCenter, ACI will create a virtual distributed switch. And then we go into vCenter, and then we add a host to the ACI VDS. So the APIC administrator creates a web profile, an application network profile. We add some EPGs, and then those get mapped one-to-one to port groups inside of vCenter. When the VMware administrator will creates VMs, then they're going to attach them, map them to different port groups, and that will add them automatically to those EPGs. The policy will get pushed to the ACI Fabric, and then we can forward traffic as defined in our application network profile. So enforcing contracts, service graphs, etc. So virtual endpoints are discovered for reachability and policy purposes by two methods. There's control plane learning. So we can do it through an out-of-band handshake through vCenter APIs. We can also do in-band handshakes, such as off-flex-enabled host, or via LDP and CDP, and now pre-provision. And then the data path learning we can learn through the DVS, learning as traffic starts to flow through DVS. So LDP or CDP is used to resolve virtual ID host to attach ports on a leaf node for non-op-flex hosts. So that's most of our ESXi hosts will be non-op-flex, of course. We can check our endpoint status. So here we have tenant 03, we have our application profiles, we've got one called web app. And under EPGs, we go to the database EPG, and then we can see the status of our endpoints. So this endpoint has been learned. We know its MAC address, its IP address. It's been learned, and then the interface that it's connected to. We can see it there. Also, the VLAN that it's been assigned to, although it's been truncated. We just have to expand it out a little bit, and we'll see what VLAN it is. So When you attach a host directly to the ACI Fabric, we'll be using LLDP or CDP. LLDP works just fine, or we can pre-provision, but typically we'll use LLDP. An AEP must be mapped, an attachable entity point profile must be attached to a VMM domain. The ESXi host discovers the neighbors via LLDP, and we communicate this information into VCenter, which is in turn provided to the APIC. In the case where we have connectivity to a B-series blade, so there's an extra step in here. There is no path for LLDP between the leaf and the UCS in the host, because the fabric interconnects here, shown here, even in end host mode, are not what the ESXi host is directly connected to. So what we can do is we can do CDP from the, or actually we can do LLDP now, as of like 2.23, I think. We can do LLDP or CDP. It'll be a separate stage for LLDP CDP, going from there to the fabric interconnects, and then from the fabric interconnects on up, we can do CDP or LDP. And it will stitch them together, and it will realize that, okay, that even though LDP is or CDP is reporting that we're connected to a fabric interconnect, through ESXi, we can stitch it together and figure out, okay, we're actually plugged into an ESXi host, and it's going through the fabric interconnect, and everything will get passed through so that the APIC can stitch it together. Of course, your other choice is to use pre-provisioning, but this works out just fine. So to do that, what we'll do in vCenter when we create our VPC policy group is we either turn on LLDP or CDP. Here we turn on CDP. And the switch profile will turn on CDP here. So this is the vSwitch. And then under the vSwitch, we'll turn on CDP. So make sure this is correct here. And as a result, the leaf detects the fabric interconnect through CDP in this case. The ESXi host detects the fabric interconnect through CDP. And the API correlates the two information to understand which fabric interconnect port is providing the connectivity to the ESXi host. So which of our uplinks here is providing connectivity to that specific host, and then we can apply our policy here. So ESXi typically is a VLAN-based hypervisor network. So ESXi with a DVS, unless you're using vShield, it's going to be VLAN-based. So hosts are assigned to VLAN ID. We'll typically map an EPG to a VLAN. So between the ESXi hosts here and the leafs, we're trunking our port groups through VLANs. So VLANs will be the encapsulation here. We can have intermediate devices in between our hosts and our leaves. So we would either need to do pre-provisioning, or we can do stitching through LLDP TLVs. So we can do LLDP here and then LLDP up here. So we can do that, or again, pre-provisioning. Okay, so to do VMware integration, you go into the VM networking tab, go to inventory, it's the only sub-tab up there. Then under whether you're doing Microsoft, OpenStack, or VMware, in this case we're doing VMware, do create VMcenter or create VCenter domain. You're going to give the virtual switch name. Then you'll pick the virtual switch. We can use either the VMware native DVS, or we can use Cisco's AVS, which is 1 kV like, or it actually is 1 kV except without the VSM. So it's like a headless 1 kV, except the control plane, instead of being the VSM, is going to be the APIC controller. So we can select either. Then we pick an attachable entity profile. We have to pick one of those. You can pick a delimiter. Pick a VLAN pool, security domains, any security domains you want to add, and then under vCenter administration credentials, they're going to click on the plus button, and then we're going to add some vCenter credentials. So we're going to create one. We'll name it vCenter DC1, give it a description if you'd like, and then we put our username and password. Then under vCenter, you've got some couple options. You can use vCenter administrator credentials, or you can create a vCenter custom role with the following privileges. We need alarms, data center, distributed switch, DV port group, folder, host, and network. So you can use either. So either just the full administrator credentials, or you can create some specific user with a custom role. So then we create our controller. So this will be either vCenter or vShield. We give it a name, give it the IP address of the controller, the DVS version, the data center. We'll need this, and then stats collection, management EPG if you have one. You don't have to specify one though. And then under associated credentials, you pick the credentials you just picked. And then under VM networking inventory, if you click on your controllers, you'll see the hypervisors listed. Now, if you don't see any hypervisors listed, typically that usually means you haven't provided the correct credentials. And then you can go into the alarms tab and it'll show you, say, hey, password invalid or something like that. But you should see them there. Under VMware, you'll see the same. You'll see the virtual switch you created. And then your uplinks, and then you can add a domain. You can add a host to that. You can add host to that vSwitch as well. So we also have the ability to control. So that's controlling vCenter from ACI. So when I create a application profile, application network profile, and then I create EPGs, it'll create port groups automatically. We can do the other way around. We can actually have vCenter control the APIC. So we do that through the APIC plugin. And then we connect a vSphere to your ACI Fabric, so it's going to use just your standard REST APIs to control it. So you give it the credentials for the APIC, and then it'll show up in the controller. So we can create tenants inside of ACI, we can give it a name. We can register subnets that need to be available. That'll go in as bridge domains, and then we can select the location for that tenant. So under here, we're going to pick ACI Fabric. And then when we go into tenants, we can see that we've created a new tenant here under ACI. And you'll see the application profiles, bridge domains, subnets will be created there, plus our private networks. So these screenshots are from version 1.0, but it's pretty much the same for the more current versions. Then we create a new ACI Port Group. So we give it the port group name. And then we pick the port group under the tenant. So we create the tenant there, click OK. And then under edit settings for a given virtual machine, on our network adapter, then we pick that port group that we just created. And then under ACI, if we take a look at our endpoint, we'll see that we've got a new virtual machine, and there's the MAC address. We've learned it through the VMM, as well as we learned it through control plane traffic. You can see this is vCenter, and then we see the in-cap. So this will show us the VLAN. This VLAN was most likely dynamically assigned. So when we created the port group, ACI just pulled one out of the VLAN pool that we configured. You can specify them manually, but it's best to just give it a pool and then just let it pick them. If you ever delete this port group, that VLAN ID will go back into the pool to be reused. You see here this host that we attached to that port group now has connectivity to its default gateway. And then under VM, we can take a look at the tenant, the ACI plugin navigation tree. We've got the ACI Fabric. We've got the tenants, and we can explore everything that we created in ACI through the plugin. We take a look at the health too. We have the health score, so that shows 100%. So there's communication back and forth. We also can take a look at all the port groups that we created. So under web servers, we see the endpoints. We see the distributed port group, related objects. And then we can view and edit VMs directly from the ACI plugin. So integration with Microsoft. We have two modes of operation. We can integrate either with just plain Service Center VMM, or we can also integrate with Azure Pack. So those are the two options. If we're going to do SCVMM, the policy management is through the APIC. So we create the application network profiles, and it goes from the APIC to the Service Center VMM. Software and licenses Windows Server with Hyper-V, as well as SCVMM. VM discovery is through OpFlex, and encapsulations are VLAN right now. NVGRE is in the future. Plug installation is manual. Under Azure Pack, so that's something you can install on top of SCVMM. It's a superset of SCVMM. Policy management can be done through the APIC or through Azure Pack. So it's kind of like the vCenter plugin. You can configure items in Azure Pack, and they'll get configured inside of APIC. Software license-wise, it's Windows Server with Hyper-V, SCVMM, and Azure Pack, and that's a free plugin. At least as far as I know, it's free right now. VM discoveries through OpFlex. Encapsulations, again, are VLAN or NVGRE in the future. And then plug installation is integrated. So here's how it looks with SCVMM. Now the animation is going to go kind of automatically here, so apologize about that. So APIC and Microsoft SCVMM initiate their handshake. Under SCVMM, we'll create a virtual switch and then attach the hypervisor to that virtual switch. Next step is we learn of the location of Hyper-V hosts through OpFlex. We'll have different Hyper-V hosts, and each one of them will have their own OpFlex running. So when they attach to a leaf, then we'll know. Step number 5 is we create an application network profile, and then we automatically map EPGs to VM networks. When we create the VMs, we'll instantiate the VMs and assign them to VM networks, and then the policy will get pushed and enforced through the APIC. Azure Pack is a integration with SCVMM. It's got a lot of nice features on it. It requires Windows Server 2012, System Center 2012 with R2 and SPF. Service Provider Foundation, and also Windows Azure Pack, of course. So Azure Pack provides a single pane of glass for definition creation and management of their cloud service. Basically, you have your provider portal, and you can create a consumer self-service portal. So consumers of your infrastructure can come in and configure things like websites, applications, databases, or just raw VMs, as well as ACI objects. So it's divided into admin and tenant portal, and then the ACI service plugin enables management of the network infrastructure, and then Azure Pack will connect through the APIC through the REST API. So that's what the REST API was built for. So it can be controlled not only from you, but also from other devices and other packages. So we've got our Server 2012 Hyper-V hosts here. We've got ACI. We've got System Center with Service Provider Foundation, and then we've got a provider portal and consumer portal up here. So when we do the integration we'll see this is a service management portal. We'll see ACI here. And we've registered our ACI Fabric as an endpoint. So we can add and configure service providers for this deployment. We can do billing and statistics per user and other admin functions under user costs. And then under ACI, we can see what services have access to this, what services this account has access to. We can see the tenant, for example, Pepsi HR, Pepsi Engineering. So these are the different endpoint groups and what tenants they're assigned to. And then resources that of ACI are currently created and consumed by this tenant. We can see everything. So we've got the tenant integration. So given tenants can see what port groups or not port groups, but what endpoint groups that they've created. So application network profiles are created through the Azure Pack. So we can either do it one way or the other way, and pushed into the APIC through the REST API. So what does that look like here? So here, rather than pushing it on the APIC, we create an application policy through Azure Pack. That we do a push network profiles we push those network profiles to the APIC. We get the VLANs allocated to each EPG. So whatever VLANs we created, it'll pull it out of a pool and report back to Azure Pack, and then Azure Pack will then go and instantiate the VMs. Oops. Going a little too fast here. So we'll create the VM networks, push those into the hypervisors. We'll instantiate the VMs. We'll indicate EPP attached. The endpoints have been attached to the leaf when the VM starts, so that gets notified through OpFlex. We push the policy to the leaf, the forwarding policy to the leaf when the VMs attach. So that's all done through Azure Pack rather than going into the APIC controller. All right, now let's talk about integration with OpenStack. So first of all, what is OpenStack? Real quick, OpenStack is a private cloud in your own data center colo. So this is, so we have, the NIST has the 4 different types of cloud: public cloud, private cloud, hybrid cloud, community cloud. So this would be under a private cloud or possibly community cloud. It has the 5 characteristics: self-service, multi-tenant, elastic, etc., as well as APIs. It was started by NASA and Rackspace, but has all the code from NASA and Rackspace has been donated to the OpenStack organization and has continued to be developed there. It's open source software, so it's free to use, free to download, free to modify. It's mostly written in Python. There's some stuff written in a little bit something else, but it's mostly written in Python. And it's comprised of a number of independent components. So these components are developed. These components are developed independently of each other, and it's released on every 6 months. So there's a new release every 6 months. Different components we have the Nova compute component. So this part is responsible for spinning up and spinning down virtual machines. We have block storage. So this provides access to block devices. Networking provides access to networking constructs, whether or not they're built-in layer 2, layer 3 constructs, or we can use neutron drivers with external devices such as ACI or even like Cisco 9K switches to create VLANs and SVIs and so forth. We've got the image service, which handles which stores the images that we use to boot off of for our virtual machines. We have object storage, which we can store these images on, or we can do things like so. This is Swift rather. Glance is the image service. Swift is the object storage service, so it's a lot like it's modeled after Amazon S3. And then we have the identity service, Keystone, which provides authentication. All of these components talk to each other through a REST API. And then we also have dashboard up here, the Horizon dashboard. So this provides a graphical user interface for users to interact with to do manual configuration. Or you can use the APIs as well. So everything that happens in ACI, so for example, everything that happens in OpenStack, for example, if Horizon, you use Horizon to spin up a virtual machine, Horizon's going to, on your behalf, communicate with the Nova compute component program and then spin up a virtual machine on your behalf. So everything's glued together through APIs. And in ACI, so we can integrate OpenStack with ACI, and we can do it in one of 2 ways. We can either do it through the Neutron driver, or we can do ML2 driver, or we can do through group-based policy. So this is the traditional way that we've integrated with OpenStack. So the APIC controller will communicate with the APIC plugin in Neutron, and it will create the VLANs or VXLANs on the leafs, as well as the SVIs. So the SVIs and the VXLANs or VLANs will be on the leafs. The networks will be created on the hypervisor host, typically KVM, and the networks will be instantiated there through on the OVS. We won't be using contracts in this method. We will be using instead IP tables. So in ACI, in OpenStack, we have the concept of security groups. They're similar to security groups in Amazon Web Services, AWS. So security enforcement is done on the hypervisors. And we use that so we have the Neutron plugin, which communicates with the APIC plugin, which also communicates with OVS. So we're orchestrating creation of virtual LANs and VXLANs on the leaves and then on the OVS for the uplinks. So the APIC driver maps via REST. So this is all done via REST APIs. Network to an EPG and router to an L3 out, also to an SVI. So the ACI Fabric offers distributed layer 2 and layer 3 without the layer 3 agent. So again, the layer 3 is done on the leaf and applied at the top of rack. The OVS applies VLAN and VXLAN tag per network. So we have the network construct in OpenStack. And IP tables is used for security groups. We have the OVS driver selects the VLAN, VXLAN tag per network and configures the OVS. So we have policy coordination there. to map the constructs in OpenStack. So in OpenStack, we call them either projects or tenants. I think people are moving more towards tenants because we have the idea of a multi-tenancy model. But in an OpenStack, especially in a private cloud, you typically are not going to have multiple customers. Well, sometimes you might, but you're typically not going to have like Coke and Pepsi as your tenants. You're going to have John and Jane or their projects or application A, application Y as your tenants. So they used to call them projects, but people pretty much call them tenants now. In ACI, of course, we have tenant. There's no OpenStack equivalent in the Neutron API mapping to an application profile. Instead, that gets instantiated when we create a tenant. Basically, the application profile gets the name of the tenant. On the networking side, a network in OpenStack is an EPG plus a bridge domain. A subnet is a subnet under that bridge domain. Security groups and security rules, since they're handled by the host, we don't do contracts. Router is an L3 context, and network external is the L3 outside. So we also have the ability to do group-based policies. So this is a second way that we can integrate ACI. It maps more towards what ACI does in terms of the policy model. It has been adopted by OpenStack, so there is wiki.openstack.org/wiki/group-based policy. And this is meant to be, Cisco started this, but has submitted it so that it's an open standard and an open way to implement policy-based forwarding inside of OpenStack versus network-based forwarding. The goal is, again, to introduce the ACI model into OpenStack. So ACI concepts, but not tied to ACI. So it's a vendor-agnostic open model. So that's a big key differentiation there. Again, introducing the ACI concepts, but not relying on ACI. But certainly we can use the ACI. So we're mapping ACI to current OpenStack components. Endpoint groups are ports plus security groups, and then contracts become security groups and security group rules. So rather than enforcing security on the host, we're enforcing them on the leaves. So this was available in the Juno release. OpenStack releases every 6 months roughly, and the commercial distributions tend to lag behind that about a couple months. Typically, I think it's April and October is when they release. So this is 2014 too. So that would have been about October of 2014. So we have the two models. We have the APIC plugin ML2 driver, and we have group-based policy. The APIC plugin, the ML2 driver, we typically will map a single application network profile to a tenant. We'll map a VLAN to a EPG, and we'll map a network to that same VLAN. So this is close to the network-centric deployment model, where we do one VLAN to one EPG to one bridge domain. And then ML2 drivers supporting existing network APIs, Neutron APIs, network routers, security groups, etc. On the group-based policy, we're mapping concepts in ACI into OpenStack in a vendor-neutral way, but that we can still use OpenStack for that, or we can use ACI for that. And we have group-based policy, the APIC group driver, and the OVS driver. So traditional ACI OpenStack integration looks like this. So we've got the APIC admin, and sorry, the animations are going off by themselves. So we have, let's go ahead and fast forward. Yeah. So we have the APIC admin, and they're responsible for creating the overall ACI Fabric. So they're going to instantiate the ACI Fabric, build the pod topology, set the route reflectors, L3 outs, etc. So they're responsible for creating the fabric itself, and then the tenants and the AEPs. So, and once that's created, the OpenStack tenant can then create network, subnet, security groups, and policies under Horizon, or they'll use the APIs. We automatically push network profiles into the APIC. The APIC creates the application network profile. Then the administrator will instantiate the virtual machines, and then the policy will get pushed into the ACI Fabric. We do have the ability to play with OpenStack in dcloud. So if you haven't taken a look at this, we invite you to take a look to dcloud.cisco.com, and you can spin up lab environments that have ACI and OpenStack integration, as well as other ACI labs as well. So if you want to play ACI, want to kick the tires, and you don't have lab equipment of your own, then you can log into dcloud and play around. And actually, dcloud is front-ended by the back end of dcloud is OpenStack. All right, let's talk about OpFlex. So OpFlex is a new extensible policy resolution protocol. So this is designed for declarative management of any data center infrastructure. So unlike legacy protocols such as OVSDB, and OpFlex was designed to offer declarative resolution. So we can do push and pull through the API. We abstract policies rather than device-specific configuration, flexible and extensible using XML and JSON, and support for any device, whether it's a virtual switch, physical switch, network services, load balancers, firewalls, etc. It is an IETF draft, so Cisco did propose this to the IETF, and it's being ratified as we speak. It is a declarative protocol rather than an explicit protocol, so it'll declare policy. So it says, I want you to be able to forward traffic from here to here. It doesn't go in and say on port Ethernet 1.1, anything that comes from MAC address XXXX or whatever, I want you to send to this port. So it allows for abstraction of network concepts so that the devices can do the actual local configuration. So policies such as who can talk to whom, what about, topology control, operations, all of these things can be abstracted so that I can use an OpFlex declaration to, for example, for a firewall, and it'll work on, the same declaration can work on an ASA as well as a Palo Alto, etc. So the way it works is we've got, through OpFlex through ACI at least, we've got our endpoint registry. We do endpoint declarations from the policy element. In this case, the policy element would likely be a leaf, or it could be a virtual switch, or it could be a firewall or load balancer or whatever. So we do an endpoint declaration to the endpoint registry. We can do an EP policy update, endpoint request. We've got our subset of our logical model. And we can do an implicit render to the concrete model, so we can push this policy to the concrete model. The concrete model is ports, VLANs, interfaces, etc. Deploy it to the network hardware, so program it into the TCAMs or the software forwarding tables. We've got policy repository. So this is where we deposit all of our policies, and that'll get pushed as a policy update. Policy resolution can be reported back to the policy repository. And all of this can be reported through to an observer for things like statistics, events, and faults. So in our APIC, we use this model. So we have our logical model, such as policy groups, rules, configurations, etc. And this is on our policy controller on the APIC. We get pushed into the leaf. So this is the leaf right here. It goes into our policy element, which represents our logical model. We can do an implicit render, which says, okay, now we're going to translate these logical concepts into what it takes to put it on the hardware. So we put it into the concrete model, which is ports, cards, interfaces, VLANs, etc. NXOS will then program it into the fib of the networking gear to the TCAMs. So we also have, so we've talked a lot about the distributed virtual switch in VMware. So that's the native vSwitch in VMware, and we use the DVS, the distributed virtual switch in ACI. We also have the option to do an AVS, application virtual switch, with OpFlex in the ACI Fabric. So the AVS is a virtual leaf that we can use to implement forwarding policy. It replaces the DVS inside of ESXi. So this will get installed onto your ESXi hosts, and it will replace the vSwitch there. So if you're familiar with the Nexus 1 KV, the Nexus 1 KV had two components to it. It had the VSM, the virtual supervisor module, and it had the VEMs, the virtual Ethernet modules. In ACI, the AVS is the VEMs. It's based off the VEMs from the Nexus 1 KV, except modified to work with OpFlex and ACI. So, and it doesn't have the VSM. So the APIC controller becomes the VSM. So we can do network policy communicated from the APIC to AVS. through OpFlex, increased control plane scale through APIC cluster and leaf nodes, and the APIC communicates with VCenter server for port group creation. So we still have that integration, that orchestration with VCenter. So the APIC will communicate OpFlex forwarding rules into the leafs. The leafs can also forward OpFlex forwarding rules into the AVS. So we do have three different options in terms of VMware integration, in terms of virtual switches. We have the DVS, like I mentioned before. The encapsulations are VLAN only. Installation, it's native. The VM discovery is through LLDP, CDP, or we can do pre-provision. And the software license are vCenter plus Enterprise Plus. So we need Enterprise Plus in order to run the DVS with ACI. We also have vCenter and vShield. Don't see many customers using vShield, but the encapsulations are VLAN and VXLAN. Installation is native. VM discovery is through LLDP or pre-provision. The vCenter license, the licenses required are Enterprise Plus vShield Manager and the vShield license. We also have the AVS, and the encapsulations are VLAN and VXLAN. Installation is through a VIB file, so we can install that either manually or through the VMware Update Manager. You can go through the console and install that there, and then do the upgrades there. So you're going to occasionally upgrade your ESXi host, so you can also upgrade the AVS switch on that as well. VM discovery is through OpFlex, so when a VM gets added to a local virtual switch, so it's on an ESXi host, it will report its status and its creation up to the API controller through OpFlex. And again, it just requires vCenter with Enterprise Plus. The AVS itself is free, so it does not require any additional licensing beyond what you get for ACI. So there have been several different modes in terms of virtually switching modes. These two on the left are mostly legacy now. When ACI first was released, we had non-switching mode or FEX mode, so it operated like a FEX. Even in the same EPG, we had to punt all of our traffic up into our leaf to get forwarded to make sure we can enforce policy there. We've got local switching mode, and this behaves a lot like how we do with DVS. Anything inside of an EPG can talk to each other without leaving the hypervisor host, because typically everything inside of an EPG can talk to each other, unless we do intra-EPG isolation, which is something different. But traditionally, VMs inside of an EPG can talk to each other, so we don't need to enforce any forwarding rules through the leaf. But from EPG to EPG, again, even if it's on the same VLAN, we need to go through the leaf in order to enforce forwarding rules. So that was local switching mode, and this operates pretty much how it does with DVS. Then we have full switching mode, where we can do full policy enforcement on the virtual machines, regardless of whether or not we're going from one EPG to another EPG or intra-EPG traffic. So this is how AVS is typically deployed these days. We can also use the Virtual Switch Update Manager, vSum, and install that to install AVS and upgrade AVS. So we can easily install 1 KV and Cisco AVS using vCenter. We can smoothly migrate VDS to 1 KV. We can upgrade and monitor, and we can do configuration. With 1 KV, we can do port profile and so forth. But in AVS, that's all done through the API controller. So no license is needed to run vSum. Ships as an OVA file. Download from CCO and use. Contains all the manager software, 1K, AVS, VEM, binaries, etc. That's a free download. And then it will show up in vCenter as a plugin. So we can use that to update and to install and or update our VEM installations of the AVS. So one thing to address here is that Cisco or VMware rather has announced, and you've probably heard of this, or you will hear this. Cisco or VMware has announced that they are not selling or providing post-sale support for Cisco AVS or any third-party virtual switch for that matter. So it's not just Cisco, but VMware has decided that they do not want to support third-party virtual switches beyond vCenter 5.5. So vCenter 6.0 and beyond, they will not provide support for a virtual switch that's not of their own design. That does not mean you cannot get support for AVS. So AVS will work on 6.0. It works fine. It works great. You get all the microsegmentation and all that. It's just that the support will come from Cisco. So post-sales support will come from Cisco for AVS. So just wanted to mention that real quickly there. So Cisco vSUM and Cisco AVS workflow, we create the AVS via the APIC. DVS and Uplink Port Group, VTEP Port Group for the VM kernel NIC is created via the VCenter connection. We enable the infrastructure VLAN and the AEP. The infrastructure VLAN, if you remember, is you pick that VLAN when you set up the APIC controller cluster. So when you first stand up an ACI Fabric, you configure the first APIC controller cluster and it asks you for an infrastructure VLAN. This VLAN should be dedicated. This VLAN will be an external VLAN, so it's going to go from your leafs to your ESXi host, and it might even go through an intermediary device. For example, maybe you have a legacy 5K that you're using to aggregate ports off of, so you need to make sure that infrastructure VLAN goes from your leaf down to your, see if I can draw this out here. So here's my ACI Fabric. So the infrastructure VLAN is what's required. So the OpFlex communications happens from the leaf, so this is the leaf, to the hypervisor, over OpFlex, over the infrastructure VLAN. So we need to make sure that infrastructure VLAN can get down to that host. And sometimes we're going to have, for example, let's say we have a legacy 5K. So it's not unusual to have a 5K. Maybe we've even got a 2K there too. We need to make sure that that infrastructure VLAN is trunked on the link between the leaf and the 5K, exists inside of the VLAN database inside of the 5K, and is trunked down to the ESXi host. So here's our hypervisor. We need to make sure that that VLAN is trunked. And what may happen is we need to make sure that we're dedicated, that whatever VLAN you picked for your infrastructure VLAN is dedicated to the infrastructure VLAN dedicated for 1KV or dedicated for AVS. It can't be used for anything else. Sometimes what will happen is an organization will deploy ACI. They decided they're not going to use the AVS yet. Then they have a new requirement, a new networking or policy requirement that requires the functionality of the AVS. So they go and deploy the AVS, and they realize they've picked a VLAN, an infrastructure VLAN. They just typed something in when they stood up the fabric, and they use something that overlaps with something else. So what you can do, and it seems scary, but it's really not, is you can do backup of your ACI Fabric. So, or actually, back up for a second. One of the issues is that you cannot, once you pick an infrastructure VLAN, you cannot change it through the APIC controller. You cannot change it through the API or the GUI or the CLI. So, if you do need to change it, what you have to do is you back up your entire ACI Fabric, which is very easy. You can do it in 1 or 2 clicks, and you should have it being backed up on a regular basis anyway. Back up your ACI Fabric. Reinstall the ACI Fabric, restand up the ACI Fabric, do it during a maintenance window, of course, and then pick the new VLAN from infrastructure VLAN from there, do a restore, and then all of your policy and forwarding will come right back up. So it does take a little bit of an outage, but it's not a long outage because the ACI Fabric can be stood up pretty quickly. So something to keep in mind. The AVS installation on the host. So we use a vSUM, or you can go in through the, I remember going in through the ESX CLI and then installing the VIB file, or you can use VMware Update Manager or vSUM. Then we add the host to AVS via vCenter, and we're good to go.